All right, we are going to learn about three types of numbers, three words to describe numbers. And we're going to use the factor game to help us remember what these words mean. All right, the first type of number that we're going to talk about is a number that you don't want to start the factor game with. That's a way to help remember it. For example, if you remember, we talked about what would have happened if I started the game or someone started the game with 30. I'm going to play against the computer now, and I'm going to choose 30. And watch what happens. The computer got all these points. Over here, we can see the point. They use factors 1, 2, 3, 5, 6, 10, 15. Those are the ones that are all in green. And what did that add up to? It added up to 42. I only got 30 points. The computer got 42 points. Obviously, that was a bad choice. Let me try something else. Maybe I'm going to try 20. 1, 2, 4, 5. Oh, the computer got all these factors. Did the computer get all the factors? No, of course. It doesn't get the 20. But the computer does get all the proper factors. Remember the factors of 20 that are not 20. That's what these are, the proper factors. And it got more points than me again. Maybe I'm using too big a number. Let me try a smaller number like 12. 1, 2, 3. What? The computer still got more points than me. 16 to my 12. And the reason is because I'm picking numbers that have a lot of proper factors, and those are called abundant numbers. Abundant numbers, as you can see, are numbers that not only have a lot of proper factors, but the proper factors add up to more than the number itself. Numbers like 30 and 20 and 12. Right? So we look at 12. What are 12's proper factors? Well, we know every number except for 1 has a proper factor of 1. And to help keep track of the proper factors, I'm going to do just like I do with factors. I'm going to make a factor tree. So a factor rainbow. So factor 1 pairs with 12. But remember, 12 is not a proper factor of 12. 12 is a factor of 12, but not a proper factor of 12. So far we have the proper factors of 12 is 1. Let's see, does 2 go into it? Yeah, it does. 2 matches up with 6. So 2 and 6 are proper factors of 12. And then 3 and 4, and I'm done. Meaning the factors of 12 are 1, 2, 3, 4, 6, and 12, but 12 is not a proper factor. The rest are still proper factors of 12. And if we add them up, like the computer did when it got its points, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 6 is, is 16. And we can say that 16 is certainly bigger than 12. So that's why this is called an abundant number. It has so many proper factors that they add up to more than the number itself. 16, which is all of them added up, is bigger than 12. And to help us remember abundant numbers, while it sounds like a good word, it's not good to start the product game with. These are numbers that are bad to start the product game with. So what kind of numbers do I want to start with? Many of you guys probably thought, well, you want to start with things like prime numbers, like 11. And 11, sure, that's great. In fact, prime numbers are the best. But there are other good numbers that are not as good as prime numbers. Numbers like, for example, 8. 8, the computer gets 1, 2, and 4. It came close to my number, but it's still less than 8. So it's not a great number to start with, but it's still okay. At least I'm winning. Another number might be something like 15. Computer gets 1, 3, and 5. That adds up to 9. I got 15. 15 is certainly not a prime number, but it's still a pretty good number to start with. So all these numbers that are good to start with, numbers that the proper factors add up to less than the number itself, those are called deficient, because deficient numbers have proper factors that add up to less than the number itself. And we looked at an example of like 15. 15's proper factors, 1 goes with 15, but 15's not a proper factor of itself. And then 3 and 5. 1 plus 3 is 4, plus 5 is 9. So all those proper factors of 15 added up to a number, 9, that is less than the number itself. So these are good numbers to start the product game with. All right, so far we've talked about abundant numbers and deficient numbers. So one would think the game is just split up between numbers that are good to play with and numbers that are bad to play with. For example, I could start with 1. Of course, I cannot. Why? There are no proper factors of 1, right? So the game doesn't let me play with something that has no proper factors. What would 2? 2 would be pretty good. It's a deficient number because 2 is bigger than the only proper factor of it is 1. 2 is a prime number. 1 and 2 are its only factors. It has 2 factors. Let's say 3, also prime, also therefore deficient. Any prime number is deficient. 4, not prime, but still deficient. I got 4 points, the computer got less, 3 points. 5, prime, 2 factors, therefore deficient. 6, 1, 2, and 3. Oh, what's going on here? 6, I got 6 points, and the computer also got 6 points. So it's not abundant, it's not deficient, and therefore we need another word for it. Numbers that the proper factors add up exactly to the number itself are called perfect, because it's so perfect that they add up so perfectly to equal the number itself. And my favorite number 28 is one of those perfect numbers. As you can see, the proper factors of 28 are 1, 2, 4, 7, 14, not 28. That's a factor of itself, but not a proper factor. So if we add up 1, 2, 4, 7, and 14, they equal 28. What a perfect number. And those are the kinds of numbers that you need to now remember these words. Perfect, deficient, and abundant. And you should write them into your journals and remember them and be able to use them.